Okay everyone, it's time to start adding, subtracting, dividing, and today multiplying fractions. We'll start with multiplying and go from there. So I'm actually going to start with some more of my drawings. You know I love my drawings here. So I'm going to do these two questions. The first one says 3 times 3/4. Okay, these are 3 wholes here. But I want to do 3 groups of 3/4. I want 3 3/4. So let's draw 3/4 and let's do it 3 times. Okay, there you go. I've divided all these wholes into quarters, and I want a 3/4, I want another 3/4, and I want another 3/4, right? I have 3 groups now of 3/4. And now I could figure out the answer, couldn't I? I mean, I'm still talking about quarters. The whole thing is quarters. And how many quarters do I have? I have 1, 2, 3 shaded. I have a 4, 5, 6 shaded, and I have a 7, 8, 9 shaded. I have 9 quarters right here. Now, it might give you a sense of what you could do here to get the answer. You could have just multiplied to 3 times 3, gotten 9, and it looks like you just keep the denominator the same. That's not actually true, but at least we got the top number. That's how you get the top numbers. You just go 3 times 3 there. Alright, if nothing else, I'm hoping these pictures give you a sense of what we mean when we multiply fractions together. Because for a lot of people, 2/3 times 4/5, they have no sense of what that even means. So here's what we do. To represent this, I'm going to start by representing 4/5. So again, I've separated this into fifths, and I want 4 of them. So I will shade in 4/5. Okay, so there's 4/5. Now, we are now going to deal with the 2/3. In fact, what we're going to deal with first is this times sign. You know what times often means in math? Especially when we're talking about fractions like this, it means of. So we want 2/3 of 4/5. In other words, you're going to look at this blue part here, and you're going to shade 2/3 of it. I know that sounds confusing, but I hope you agree with me. If I put one line here, and another one around here, what I can do is I can shade in this part, only this part, and I have shaded in 2/3 of the blue, right? This was all blue, but now I've made 2/3 of it green. So I've shaded in 2/3 of 4/5. So now if I extend these lines down, I'll do it dotted, but if I go here and I go here, just extend those down, now I can get my final answer. The final answer is the green. How much of the whole, remember the whole was the entire square, how much of the whole is shaded by the green? Well, let's figure this out. How many different sections, even pieces do we have in the whole thing? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So our bottom number is going to be 15. How many of them are shaded green? 1, 2, 3, 4, 5, 6, 7, 8. 8/15 is our answer. Now, hopefully a few of you understood what I did there. I can show you again in class if you want. I think it's kind of cool, actually. So if you look at the question, do you see how we could have gotten 8/15? Sure, you see it. You just multiply 2 times 4 across the top, you get 8. And you multiply 3 times 5 along the bottom, you get 15. Hey, multiplying fractions isn't actually that bad, is it? So let's go up and write some notes for multiplying fractions. I'm going to start actually with the final note I have down here, which is you're going to multiply the numerators together, you're going to multiply the denominators together. That's how you multiply fractions. Now, a couple other points. Point 1 is you do not need common denominators. Okay, we haven't talked about common denominators yet. We will talk about them when we add and subtract, but you don't need them for multiplying. Common denominators is when you have to get the same number on the bottom of both fractions. You can, you're just making your life way more difficult though if you do it, so don't do it. And the last point I have for you is going to seem kind of strange. You can simplify, I call it ninja slicing, before you multiply. So I'll show you what I mean in just a second here. So let's look at a few questions. So first of all, 4/5 times 9/11. Remember, you don't need a common denominator. So you're ready to multiply right now. You can multiply across the top. You can multiply across the bottom. 4 times 9, 36. 5 times 11, 55. Make sure it's in lowest terms. Is there anything that goes into both of these? 3 goes into this, but not this. 5, no, that's it. You're finished. Done. Okay, next one. Now, 1 times 18 is 18. 6 times 19 is some big number. Oh boy, I wish I could simplify this, make it easier. You can. Okay, so this is the thing I'm talking about, the ninja slicing. Right up here I talked about ninja slicing. So what this means is if you can find one number in a numerator position, so that's one of these two numbers, and one number in the denominator position, that's these two numbers, can you find a pair of those numbers that you can divide by the same thing? I see it. Do you see it? You can divide both the 6 and the 18 by the same thing. What goes into 6 and also goes into 18? Well, you could divide them both by 2. That's true, but pick something bigger. You could divide them both by 3. That's good too, but there's something even bigger than that. You could divide them both by 6. So you can do this before you multiply, and I strongly encourage you to do this. It'll make your life a lot easier. We could say, okay, 6 goes into 6 one time, so I'll put 1, and 6 goes into 18 3 times, so I'll put 3. Those are my new numbers I'm going to use. Okay, now I can multiply like normal. 1 times 3 is 3, and 1 times 19 is 19. Boy, that was easier than going 6 times 19. Now you might be wondering, why didn't I do that back here? Because I can't. Is there a number that I can divide either one of these by and also divide any of those by the same thing? No, there's nothing I can divide 4 by and 5 or 4 and 11 or 9 by. It just doesn't work. So remember, it has to be one number on the top. It has to be one number on the bottom. Some people call this cross-canceling. I'm not a huge fan of cross-canceling because they don't have to be across from each other. So for example, in this question right here, you could simplify the 15 and the 21. You could divide them both by 3. Or you could do the 15 and the 10. You could divide them both by 5. Let's do that. Why not? So I divide them both by 5, the 15 and the 10. 15 divided by 5 is 3. 10 divided by 5 is 2. Is there anything else you can still simplify? Yeah, there is. You can simplify the 3 and the 21 if you want, or you could do the 7 and the 21. Either one of those will work. I'm going to do the 7 and the 21. I can divide them both by 7. 7 divided by 7 is 1. 21 divided by 7 is 3. Hey, is there still anything you can simplify? As long as there's something in the top and something in the bottom, you can do it. There absolutely is. I can divide the 3 and the 3 by 3. So 3 divided by 3 is 1, and 3 divided by 3 is 1. Awesome. Wow, look at this. Now all I'm left with is 1 times 1 is 1, and 1 times 2 is 2, and I have my answer. Now, if you didn't do all this simplifying, you can still get the right answer. You'll just have to do lots of simplifying at the end of the question instead of the start of the question. And look, if we look back, what it means you would have had to do is 15 times 7, which isn't really that easy, and 21 times 10, which is not that bad, but then you'd have to put it in lowest terms, which can be a bit of a drag. So I strongly encourage you to look to see if you can ninja slice. I call it ninja slicing because it's kind of like when you do it, you're like, hiya, hiya, you're slapping it, and I don't know, we started talking about that years ago in my class. So let's simplify this. See some stuff you can cancel? Oh, there's all sorts of stuff you can do here. You could do, I don't know, I'll do the 4 and the 20 this time. So 4 and 20 can both be divided by 4. So you get 1 and 5. 20 by 4 is 5. 25 and 30 you could do. Divide them both by 5, you get 5 and you get 6. Anything else you could do? Absolutely. You have a 5 and a 5. Divide them both by 5, you get 1 and 1. And now we can get our answer. 1 times 1 is 1. 1 times 6 is 6. Great. Whoa, what are we going to do here? Just 15. That's not a fraction. Well, why don't we make it a fraction? You can make any whole number a fraction by putting it over 1. You can always put a number over 1 and turn it into a fraction. So now, do you see any canceling you can do? Any ninja slicing? I do. I see the 15 and the 10. Divide them both by 5. 15 by 5 is 3. 10 by 5 is 2. Now we can multiply. 3 times 3 is 9, and 1 times 2 is 2. I'm totally okay with this answer. If you want to leave your answer like that, I'm okay with that. Or you can switch it into mixed. How many 2's go into 9? 4. 4 2's get you up to 8. You have 1 left over, so that's your remainder, and the denominator stays the same, 4.5. Either one of these answers is fine with me. Okay, 6 over 7 times 21. Whoa, wait a minute. It's not a fraction. What can you put it over? Put it over 1. Can you do any ninja slicing? Absolutely. The 7 and the 21. So 7 divided by 7 is 1, and 21 divided by 7 is 3. Question for you. Can you now simplify the 6 and the 3, divide them both by 3? No, you can't do that. How come? It has to be one number in the numerator, one number in the top, and one in the bottom. Those are both numerators, so it doesn't work. It has to be one on the top, one on the bottom. Okay, now we can multiply. 6 times 3 is 18. 1 times 1 is 1. All right, this is good. It's right. If it's 18 over 1, do you know what I want you to write? Just call it 18, right? These are exactly equivalent to each other, and we always in math want things to be as simple as possible. So if we can leave out that over 1, please do so. This is the best answer. I wouldn't mark this wrong. I would just grimace a bit when I mark your work. You don't want that. Okay, oh my gosh, look, we're multiplying 3 things together. If there's nothing in between, it means multiply and multiply. Now, I can ninja slice here anywhere I want, as long as something on the top, something on the bottom. So, I don't know. An obvious one I see here is the 11 and 44. I don't know how good you are with your 11 times table, but I can divide them both by 11. 11 by 11 is 1. 44 by 11 is 4. Okay, what else you see? I see 5 and 10 right here. Why don't we do that? Divide them both by 5. 5 divided by 5 is 1. 10 divided by 5 is 2. Anything else? Yep, the 5 and the 45. Divide them both by 5. 5 by 5 is 1. 45 by 5 is 9. Anything else? Yes. There's the 2 and the 4. Divide them both by 2. 2 by 2 is 1. 4 by 2 is 2. And now we can finally get our answer. 1 times 2 times 1 is just 2. 1 times 9 times 1 is 9. Again, if you missed any of this simplifying, that's fine. You'll just have to put it in lowest terms after. Okay, next. Well, we have this one big 14 here. Why don't we make it 14 over 1? And now we're good to go. Let's look for some canceling here. 7 and 14 is good. Divide them both by 7, you get 1, and 14 by 7 is 2. The 9 and the 18, 9 by 9, divide it by 9, you get 1, and 18 by 9 is 2. What else? How about the 6 and the 20? Divide them both by 2, you get 3, and you get 10. You can go more. How about the 10 and the 8? Divide them both by 2, you get 5, and you get 4. And I think that's it. There's nothing else you can simplify with this 5 here. So on the top, you have 3 times 2 is 6, times 2 is 12, times 4 is 48. And on the bottom, you have 1 times 5 is 5, times 1 times 1, it's still 5. That's fine with me if you have that answer. Or, how many times does 5 go into 48? 9 times gets you up to 45. You have 3 left over. So either one of those is good. And one more. Again, we have a whole number. Let's put it over 1. Let's do our simplifying. What do you notice? 5 and 5 is nice. Let's do that. Divide them both by 5 and you get 1 and 1. We've got 6 and 2. So divide them by 2, you get 3 and 1. And wait a minute, I got 3 and 3. Divide them both by 3 and I get 1 and 1. Whoa, I got 1 times 1 times 1, which is 1. And I got 1 times 1 times 1, which is 1. 1 over 1. Guess what I want you to put? 1. That's the best answer. Alright, one word problem for you here. In my daughter's class, 4/5 of the kids are in grade 1, the rest are in grade 2. It's a split class. Of the grade 1 students, 3/4 of them have learned how to read. What fraction of the grade 1 students are able to read? I know these can be hard, can't they? So 4/5 of the kids are in grade 1, and 3/4 of those kids know how to read. So what we want to know is, what's 3/4 of 4/5? That's basically what we're trying to figure out. What's 3/4 of that amount of kids? Well, remember what of means? We just talked about on the other side of this page. 3/4 of means 3/4 times 4/5. Any ninja slicing you can do here? For sure, the 4 and the 4. Divide them both by 4, you get 1 and 1. So you end up with the answer, 3 times 1 is 3, 1 times 5 is 5. 3/5 of the grade 1 students are able to read. What fraction of the grade 1 students are not able to read? Well, this isn't a multiplying question. This is to see if you understand fractions question. If 3/5, so there you go, 3 out of 5, this is my 3/5 that can read. These are the ones that can read. They are able to read, 3/5. Then these are the ones that can't read. What fraction is that? 2/5. So our answer is 2/5. Why does that make sense? Because there's only kids that read and kids that don't read. And if we're talking about fifths, what should they add up to? It should add up to the whole amount, which is 5/5. In this case, it does. So you didn't need to draw the picture. You could have said, well, 3 out of 5 are able to read, then the missing 2 out of 5 can't read, right? Alright everyone, that's multiplying fractions. Next day, division.